actually going to start with some old-fashioned teaching materials here. I have a globe of the Earth in bright color, and a globe of the Moon, which is actually about the correct scale for this globe of the Earth. Okay, so that the Moon is about the size of North America. It's more or less 1/4 the diameter of the Earth. Sean's moon is bigger than mine, but that's okay because it's not to scale. Yeah, we won't even go there. In terms of the position and orbits of these two, in order to kind of illustrate this, I need a volunteer. Volunteer from the studio audience. Yeah, I'm going to come on out. Which would you like? The moon? All right, you can be the moon. All right. So, now, did you cheat and look at the sheet? Do you know how far we're talking? Okay. Because the answer is on. Nobody look. Okay. Now, what we're going to do is we're going to separate here and try to estimate, using this scale, the distance between the Earth and the Moon. Okay? So, I'm going to ask you to kind of back up that way, and I'm going to back up this way. And people can shout out when they think we're about the right distance, okay?
Stop. Keep going.
No, keep going. Okay. You're going to have to go upstairs. Keep going.
Okay, I'll go this way.
Keep going.
Further.
Keep going.
Keep going. Okay, bye. I'm just going to stop.
Right about there.
That's good.
Okay. Using this scale, 10 meters would be the distance between the Earth and the Moon. Okay. The distance is 385,000 kilometers. Thank you. 385,000 kilometers, or about 30 times the diameter of the Earth. Okay. So a lot of the diagrams I use will not be to scale, because to scale on this screen, you know, the Earth would only be this big and the Moon would be too small to see. Now you know why it takes 3 days to get there. Okay, it's not close. Okay, so some of the fast facts. These are on your handout. The size of the Moon, diameter of the Moon, is 3,475 kilometers, or roughly the size of North America. And the distance, the 385,000 kilometers, is kind of an average distance. The orbit, as we will see, is not circular. Okay, it's not an equal distance always. It's an elliptical orbit, so sometimes it's closer and sometimes it's farther away. At its closest, it's about 357,000 kilometers, and at its farthest away, it's about 407,000 kilometers. And even that sort of varies from time to time, because as we will see, the orbit is also kind of tilted. But more or less, those are the values. The period for one 360-degree orbit of the Moon around the Earth is 27.32 days. But the time for one lunar cycle, from new moon to new moon, is 29.5 days. And if you stop and think about that for a minute, you kind of shake your head and scratch your head and think, well, why is that? The reason is that the Moon is not the only thing that's moving. Okay? If we look at the Moon's orbit around the Earth, one 360-degree cycle of the Moon around the Earth is 27.32 days. During that time, the Earth is working its way around the Sun. Okay, that's almost a month. That's about a 13th of a year. Okay? During that time, the Earth is going to swing, 26 degrees or so around the Sun. So if you notice the position of the Moon here, I can point here, but up here, it's not in line with the Sun anymore. So this is not a new moon. A new moon occurs when the Moon is sitting in front of the Sun. Okay? Here we have a direct line between the Sun and the Moon and the Earth, so we'll call that a new moon. Up here, the Moon is not in line with the Sun. In order for the Moon to get in line with the Sun, it has to move a little bit further. Okay? Okay? And so it's 29.5 days for one lunar cycle, even though one full orbit is only 27.25 days. Okay? Does that make sense? It's one of those trivia things you can freak people out with. The orbital plane is tilted. So here we have the ecliptic, which is the plane, the orbit of the Earth around the Sun, and the Moon is tilted at about 5 degrees. It's 5.16 degrees from the ecliptic. So the orbit of the Moon is not exactly in the same plane.
That's why we don't have an eclipse every month.
Which is why we don't have an eclipse every month. Exactly. Okay? As I mentioned, that the orbit is elliptical. This is a bit exaggerated, obviously. So remember that the closest distance was 357,000, and the farthest distance is 407,000, and sort of the mid-distance is about 385,000 kilometers. Okay? Now, as was mentioned, one of the questions, why is the same face always facing the Earth? That has to do with something being called tidally locked. Okay? The tide is an influence, a gravitational influence, and the Earth is a lot bigger than the Moon. Okay? The Earth is quite a bit more massive than the Moon, and the gravitational influence on the Earth is such that it keeps pulling on the same face, so that in the early age of the Moon, long, long ago, that gravitational influence was such that it slowed the rotation, and I'll explain shortly how that works. It slowed the rotation of the Moon so that the same side of the Moon is always kind of stuck facing the Earth. But here's a trick. It's not actually facing the Earth. Okay? It's facing this point which is kind of in the middle of the ellipse. Okay, so it looks like it's facing us, but it's not really facing us. It's facing that midpoint. So if we're somewhere else on the orbit of the Moon, or if the Moon is somewhere else in the orbit around the Earth, you see that face is not actually facing directly at us. Okay, again, this is slightly exaggerated, but you can see the face of the Moon is facing this point here. In other words, when we look at the Moon, we're not looking at that midpoint. Okay, we're not looking straight on the Moon as we would here. We're looking a little bit off to one side here and a little bit off to the other side here. So the day-to-day, as we watch the Moon actually wobbles a little bit. It does kind of this little rolly wobble thing. And that we refer to as libration. And what that means is we can actually see from Earth, without even lifting our feet off the ground, we can see more than 50% of the surface of the Moon. Because sometimes one side is a little bit tilted towards us, and sometimes another side is a little bit tilted towards us. In the Observer's Handbook, in the monthly calendar section, you will notice on the Moon diagrams there's a little dot. Okay? That the size and position of that dot represents the magnitude of the libration of the tilt, or of the wobble. Also, you will see that that little dot kind of, it's not just moving from one side to the other, it's kind of going around a little bit. That's again because the orbit is tilted. So sometimes when it's low in the orbit, we're seeing, you know, we're kind of peeking over the top of the Moon a little bit, and when it's high in its orbit, we're kind of peeking under the South Pole a little bit. Okay? So with all of that, we can see more than 50%, and I don't remember the exact, 59% of the surface of the Moon. Okay? Which is really kind of neat.